When an equation represents a function, kind of like the last one we just looked at, I'll write a slightly less complicated version over here. Oh, I got one down below. Y equals 5x minus 1. The domain is called the independent variable. And for most basic functions, that is always going to be the x. Well, we can't really see that. The independent is usually the x. But sometimes it's the t, sometimes it's the number of items bought. It can depend on the situation of the problem. But when it's just the generic x and y, it's the x. The dependent variable, that is always the y numbers. And same thing if it's like a cost function. How many did you buy? What's the cost? The cost is the dependent variable because it depends on how many you buy. We use function notation to take what is a nice, easy to read function and change its format a little bit so that it's more convenient for some things. Here, everyone should be able to graph y equals 5x minus 1 at this point. But if we do something and say, let y equal f of x, it changes this whole function into f of x equals 5x minus 1. So what happens is we're changing the format so that it is a little bit more convenient for a couple different things. Now right away, it's not going to look that much more convenient, but trust me, we're going to start doing things later on like f composed with g of x. And that has a whole new meaning to it, and you have to know what the function f is and what the function g is and how they work together like this. So it might seem like a little kind of extraneous work at this point, but it will come in very handy eventually. An important thing here is when you write it down like f of 2, that means you're plugging in 2 for all the x values. And I know, just doing a quick calculation in my head, that that's 9. One of the reasons why this is valuable in the beginning is that tells me the coordinate 2, 9 is one of the points on the graph. So evaluating a function in this way really makes things easy for labeling specific points on a graph. All right, and here we are given a specific function, f of x equals 2x squared minus 8. This whole bad boy here, and we're going to evaluate it, which means when I have f of 6, everywhere there was an x in the definition of the function, I am going to write a 6. And now I just do my normal calculation. 6 squared is 36. 2 times 36 is 72. And that tells me f of 6 equals, subtract 2, that's 64. There you go. That's how you evaluate it. And because all we're doing is taking whatever the input is, in part B it's 2y, and plugging in for the x, all we have to do then is simplify it if we're ever asked to do this. Now, and when it's a number, that's easy. Just do order of operations. When it's a function, or when it's a algebraic expression you're plugging in, you still do the same thing. 2 goes into, or 2 times whatever x is squared minus 8. And this time, see if it can fit in there. I'll write it in red again. 2y is what the input is. So now I need to square 2y, which means I have 2 squared and y squared. 2 times 4 is 8, y squared minus 8 equals f of 2y. And there is my result.